We are now going to be learning how to use the sum and products of roots in solving certain quadratic equations. We are given that alpha and beta are the roots of a quadratic equation. Now, if we're given the roots of a quadratic equation and we've been asked to use them to get the original quadratic equation, how do we usually solve it? We usually open up two brackets, equate them to 0. So we have x here, we have x here. We have negative alpha, that's negative one of the roots, and negative one of the roots, the other root. We are going to open up these brackets. We have x multiplying x is x squared, x multiplying beta is minus beta x. We now go over to multiplying by alpha. Negative alpha multiplying x is negative alpha x, and negative alpha multiplying negative beta is plus alpha beta, and they are all equal to 0. We'll collect like terms now. We have that x squared, and we have negative here. We have these are the coefficients of x, beta and alpha. Both of them have negative values. So let's collect that negative. Is a common term there. So we can now have alpha plus beta. Yes, I know beta plus alpha, but alpha comes before beta. So, and it's addition. Addition is commutative. That's, it doesn't matter which one comes first and which one comes last. When you add up things, whether you add 1 plus 2, it's equal to 3, or you add 2 plus 1 is equal to 3. That is what we mean by they are commutative. So we are going to say alpha plus beta, and of course they are the coefficients of x plus alpha beta equal to 0. So this is what we actually mean by saying sum and product of roots. So when given the roots of an equation, you can get back the original equation by having just the sum and the product of roots in this place where they are given. Now we will be solving certain examples that will help us to be able to recognize the sum and products of roots of certain questions. Now let's go over to the examples. We've been given this equation and we've been asked to find the sum and products of this quadratic equation. Now you can see this equation, we have to rearrange it to look like our typical equation. We have y squared plus 5y is equal to 1. We have to rearrange it to look like a typical quadratic equation. We have y squared, the one that comes with a squared comes first. The one that comes with the unknown alone, that's 5y, comes second. Then the constant comes last. Now, our constant is on the other side of the equation. We send it over, it becomes negative 1 on this side is equal to 0. So we've rearranged this to look like a typical quadratic equation. Now, the next thing we are going to do is we are going to find out what our sum and products are. Now, when we compare with this equation, with this equation, this 5 is actually going to be here, and this 1 is actually going to be here. Now, when we consider, negative has a way of changing the value of what we have, like it has a way of turning the sign of a number, but positive does not have an effect in the sign a number carries. And considering that the unknown squared has a coefficient of 1, so we don't really need to divide anything. All we do is we are going to say that the sum is equal to negative 5, and the product AB, that's alpha beta, is equal to negative 1. Now, why did we say negative 5? The sum has to carry the opposite sign of what it originally carries in the equation, and the product does not change. Its sign is its sign. We'll solve further examples to help us. understand this better. Because of this negative, that is why this has to change. So let's say we have this other equation. We have a into a, okay, minus 1 is equal to 5. Now, this does not look like a quadratic equation. Really? It doesn't look like a quadratic equation, but this is a quadratic equation when we open up this bracket. Now, when we open up the bracket, we have a times a, we have a squared, and then a times minus 1 is minus a is equal to 5. Now we rearrange. When we rearrange, we have a squared minus a. Then the 5 comes over to become minus 5 is equal to 0. We can see that this is a quadratic equation right now. Now, remember, our sum, that's alpha plus beta, has to carry the opposite sign of the coefficient of the unknown alone, that's a. So the coefficient of a is negative 1. Therefore, this one carries the opposite sign, which is just a plus 1. And then the product, alpha beta, has to carry the sign the constant carries, which is minus 5. So you can see it's just easy. Change the sign of the coefficient of this, and this other one carries just the way the constant is. Now let's solve one more example. We have x plus 1 over x is equal to 3. Now, this again does not look like a quadratic equation at the first glance, but when we take away this fraction, we are going to get this as a quadratic equation. Now, to take away this denominator x, we have to multiply all through by x. So when we multiply all through by x, what do we mean by that? X multiplying x plus 1 over x is equal to 3. So this other side included. We now have x times x is x squared, x times 1 over x, so the x cancels x, we have plus 1 is equal to x times 3 is 3x. Now when we rearrange, we have x squared, this comes over to become negative 3x, and then plus 1 equal to 0. Now this is more like it. This is now our quadratic equation. Now our sum, alpha plus beta, is equal to, we have negative 3 here, right? So it becomes just 3. And the product, alpha beta, is equal to, that's right, 1 plus 1. So we can see recognizing the sum and product of roots from a given quadratic equation is just easy. Change the sign of coefficient of x, and the constant just stands alone. Now we are going to be seeing the sum and products of roots, and we are going to be deriving the original equation from a given sum and product of roots in the next example. Now we've been tasked to find the equation whose sum and product of roots are respectively negative 5 and 6. So the first thing we do is we recognize that the sum, that's alpha plus beta, is equal to negative 5, and the product, which is alpha beta, is equal to 6. So this is what it is. Now what is this equation? We have to come back to this equation that says that x minus alpha plus beta, x plus alpha beta equal to 0. You remember this equation? That's when we opened up the bracket that has alpha and beta, like when we got back the equation from the given roots. So all we need to do is to substitute these values into this equation. So always remember the way this equation is. Remember that the coefficient of x squared, the coefficient of squared of x carries negative. That means the sign has to change, and the product, which is the constant, which represents the constant, the sign doesn't change. So what do we mean by that? We are going to say x squared minus from the formula, and what we have here is minus 5, right? X, do you understand? We substituted, plus 6, just 6. That's alpha beta is just 6. equal to 0. So we have x squared minus minus 5 is a plus 5x plus 6 is equal to 0. So this is the original equation that has this minus 5 and 6 as its sum and product of the roots. Now let's see another one. Let's say the sum and product of roots are 0 and 7. Now this looks weird, right? Meaning that alpha plus beta is equal to 0 and alpha beta is equal to 7. Now same thing, we have that the equation has to look this way: alpha plus beta equal to 0. So we simply substitute. We have x squared minus alpha plus beta is 0, 0x, plus whatever alpha beta is, 7 in this case. Now 0x is nothing, so we are left with x squared plus 7 is equal to 0 as the original equation. You can see where it's going, right? It's easy. Let's solve one more. We have another equation whose sum and product of its roots are that sum alpha plus beta is equal to negative 7 over 3, and alpha beta in this case now is 0. So we are trying out different ways to see how to tackle each new form we have. Now we have that the original equation, I always like to write out whatever my original equation is, so I don't make any mistake when substituting values. And it's important you do so too. The chances of making mistake is now minimized. We have x squared minus alpha plus beta is minus 7 over 3. So this minus from the formula and this other one from the given value. X plus alpha beta is 0. We have x squared, negative times negative, that makes this plus 7 over 3x. This is already 0, so we don't have a constant in this case. Now we can't work with fractions. We have to multiply all through by this denominator, which is 3. So when we multiply all through, we have 3x squared plus 7x is equal to 0. Therefore, this is the original equation. Now, let's solve one more where we have decimal values. Now, we've been given that the sum is equal to 1.2 and the product is equal to 0.8. We are to get the original equation. Simple. When we have x squared negative the sum alpha plus beta x and plus alpha beta equal to 0. So we simply substitute. We have x squared negative from the formula and 1.2 given 1.2x plus alpha beta, which is 0.8 equal to 0. Now, let me have my rough work side again. 1.2, we have to change these to fractions. 1.2 is 12 over 10, right? And then to its lowest term, 2 can go. We have 6 over 5. So we are going to replace that here. We have x squared minus 6 over 5x plus, we have that 0.8 is like 8 over 10. And when we reduce to its lowest term, we have 4 over 5. So we have 4 over 5 equal to 0. Now we can see what we have to multiply all through by. We multiply all through by the denominator, which is 5, so as to remove the fraction from this. When we multiply all through by 5, we have 5x squared minus 6x plus 4 equal to 0. So this was the original equation. So from this video, all you do is to practice how to recognize the sum and product of roots from a given equation, and also how to how to get the original equation from a given sum and product of roots.